What if humanity is about to do something that sounds impossible? Not travel faster than light, not build a warp drive, but actually manipulate gravity itself using lasers. For over a century, gravity has been treated as something we can only observe, never control. But now, a physicist has proposed a radical experiment that suggests laser light could exchange tiny amounts of energy with gravitational waves. The ripples in spacetime first predicted by Einstein. If this works, it could become one of the most important experiments in modern physics. Because it might finally reveal whether gravity itself is quantum in nature. And yes, this is real published science. Gravity is weird. It's the weakest force in nature, yet it shapes galaxies, bends light, and creates black holes. But despite all we've learned, gravity has remained stubbornly separate from quantum mechanics. The laws governing atoms and particles work beautifully. Einstein's theory of gravity works beautifully, but together, they don't fit. And now, in 2026, a new proposal has emerged that sounds almost unbelievable. Can laser light directly interact with gravitational waves? Can we transfer energy between light and gravity? If the answer is yes, could we finally uncover one of the greatest missing pieces in physics? You might think gravity is already solved. After all, Einstein gave us general relativity back in 1915. According to his theory, gravity isn't really a force. Instead, massive objects bend space-time itself. But there's a huge problem. The rest of physics operates according to quantum mechanics. Electromagnetism has photons. The strong force has gluons. Every fundamental interaction has a quantum description. Except gravity. Physicists suspect gravity should also have a quantum particle called the graviton. But despite decades of searching, nobody has ever detected one. Gravity is so weak that building an experiment has seemed almost impossible. Perhaps the answer lies in something we already know how to control with incredible precision. Light. A physicist proposed a bold experiment involving powerful laser systems and gravitational waves. These waves were finally detected in 2015. Those waves stretched and squeezed space itself. And scientists detected changes smaller than a proton. According to the proposal, laser beams could exchange tiny amounts of energy with these waves. Think of it like musicians exchanging vibrations. The energy transfers would be unimaginably small. But modern laser technology has become astonishingly precise. Instead of simply detecting waves, scientists want to actively influence the interaction. Not create anti-gravity, but manipulate the exchange of energy. Because if gravity behaves according to quantum rules, the interaction should leave detectable signatures. Tiny fingerprints revealing the hidden structure of space-time. Quantum gravity is one of the greatest unsolved mysteries in science. General relativity explains large scales. Quantum mechanics explains tiny scales. But inside black holes, or during the Big Bang, these theories break down. Something deeper must exist. Scientists have proposed many ideas. String theory, loop quantum gravity, extra dimensions, quantum foam. It might reveal whether spacetime itself is fundamentally smooth or composed of tiny quantum building blocks. Though it's important to remember, nobody expects anti-gravity machines next year. This is basic science. But history has shown that understanding nature often leads to revolutionary technologies decades later. Headlines about gravity manipulation can sound dramatic, but scientists are not building tractor beams. In fact, proving these interactions exist would already be a monumental achievement. It would represent a bridge between Einstein's universe and the quantum world. Human beings, tiny creatures living on a small planet, could be approaching answers to questions that have existed since the birth of science itself. Questions about what spacetime really is. Questions about how the universe began. Sometimes the most important discoveries begin with ideas that sound ridiculous. Flying machines and landing on the moon once sounded ridiculous. Maybe the experiment won't work, or maybe future generations will look back at this as the first steps toward understanding the deepest mysteries. If you enjoyed exploring the strangest ideas in space and physics, make sure to subscribe to Exo Files. We'll see you in the next file.